Hello and welcome. So today we are going to start with new subject, that is probability and statistics. So what I am going to do is same as what I have done for the linear algebra. So if you are already following me, then you have observed that so far in linear algebra we have covered last 5 year paper from statistics, from mathematics, and from EC, and this will be continue. Next I will be covering CS, then IT. So, and maybe if we get the time, then W also. So what I am doing, that whatever the linear algebra questions are from these subject, that we are practicing and we are solving those questions, right? And also I'm keeping in mind that we are picking only those questions that in lines with the syllabus of this data science and artificial intelligence. So in linear algebra we have covered all these three subjects of last 5 year, and we are going to continue with these. And if time permits, then maybe again I will pick last 5 to 5 year, and we will be solving. We will be continue with that. Right now here, what I am going to do is I will pick the for the probability and statistics. I will pick first that statistics paper, and let's look at how many question we have. And obviously that in statistics paper, that probability and these statistics are the core thing. Then obviously here you will get the question that will have the difficulty level, right? So it would be not easy to solve all these questions with clear concept, right? But I will try my best to solve all those questions, so that you get the benefit of like from where these questions are, and you can solve more similar type of question, right? Okay, so let's start with today 2019 paper and statistics. Then we will solve 20, 21, 23, 24. Sorry, up to 23 in statistics. Then we will jump to maybe I will look at the mathematics paper, and I will look if those questions are getting in line with this data science and artificial intelligence syllabus. Then we will solve those. So I have already looked at the question, and I have picked already few of the questions that I am going to solve today. So there are a lot of questions in probability in this paper, so in a statistics paper. So and more, and there are a lot of question that is more advanced, or that is not in the syllabus of data science and artificial intelligence. So we are going to ignore that kind of question, right? Because we cannot cover a lot of concepts, and also our main focus is on this paper, right? So we will select those questions only. Okay, so let's pick our question. I hope question is visible to you. Okay, so the first question is question number 3. So I have made the space for the writing, because their space is too less, and these questions are little bit needs little bit of calculation. So I have to make the space for that calculation, right? So let's look at this question number 3. So if you look at this question number 3, so we have let 1 to 3 represents the outcome. Let me zoom out a little bit because it is too small, I think. Okay, so 1 2 3 4 represents the outcome of the random experiment, and we have given that all are equally probable, and with equally probable the probability is given 1 by 4, right? Suppose, and now we have given these subset, or you can call this event, that a1, a2, a3 and a4, right? So these are the events we have given. Then we have been asked that which of the following statement is true. So first of all, we will have to look at this, that which of the event are independent. So we will go through these options and we will check for the independent condition, right? Okay, so let's solve this question number 3, right? So okay, so okay, so let's look at this event a1. So a1 is equal to, we have the true element in a1, right? And we have given that the what we have given, that these 1, 2, 3, 4, these are equally probable and is having the probability 1 by 4. So if I ask that what will be the probability of this a1 event, since we have this 2 element, right, out of 4 we have here 2 element, then probability of a1 will be 2 divided by 4, that is 1 by 2, right? Okay, and let's calculate this probability of a2 also. So a2 event have the 2 elements, that is 2, 3, and it will come out same 1 by 2. Calculate this probability of a3, that is 3, 4, again it will be 1 by 2. And a4, we have given 3 elements, right? Here a4, 1, 2, 3. So 1, 2, 3, and the probability of a4 will be, so 3 out of 4, right? So 3 by 4. Now let's go through the first option, option A, right? So so option A, a1 and a2 are not independent. That means not independent means independent, dependent, sorry. Not independent means a1, I will have to check that a1 and a2 are dependent. So so if two events, so I will have to check for a1, a2, right? So if we have given two events, then probability of a1 intersection a2, if these two are independent events, then I can write it as individual product of individual probability, right? Because these two events are independent. So this is the condition for independent, right? So now if you calculate this left hand side, so if you look at this set A having this 1, 2, right, and set B having this 2, 3, and if I ask you that what will be the a1 intersection a2, so the common element is 2. So this will become probability of 2, right? And if you calculate this left hand side, the probability of 2 out of this 4 will be 1 divided by 4, right? And if you calculate this right hand side, the probability of event a1 is 1 by 2, and probability of this event a2 is 1 by 2. So 1 by 2 into 1 by 2, that is 1 by 4. So this left hand side and right hand side are equal, so we can say that a1 and a2 are independent, right? So this option is incorrect because it is given that it is not independent, right? Similarly, we can check for now option B. what we'll have to check between a3 and a4. Let's check. So probability of a3 intersection a4, it should be, if these are two independent events, then it should be equals to probability of a3 into probability of a4. Let's calculate this intersection. So in a2 and a3, the intersection will be this 3 3. So it will be equal to probability of 3, that will be 1 by 2, right? And if I calculate this probability of right hand side a3 and a4, it will be 1 by 2, that is this one and this one, so equal to 1 by 4. So if you see, these two are not equal, so these two events are not independent, so these two events are dependent. If you look at the option 2 is incorrect. Now let's check this option C. In option C, we will have to check between a1 and a4, right? So if you look at this a1 and a4, the intersection is this 1 2 and 1 2. So so here we will find that probability 1 2, right? So it will be 2 divided by 4, that is 1 by 2. And again we will find the individual probability, that is, if these two events are independent, then a1 into probability of a4, right? So a1 is 1 by 2 and a4 is 3 by 4. So we have got 3 by 8, and these two are not equal, that means they are dependent. They are dependent, that means they are not independent, right? So option C is correct. A2 and A4 are not independent, that means they are dependent. So they are dependent because this condition is not getting satisfied, right? Similarly, you can check for this option D, and that will be false, right? And if you have already looked at the sample paper, similar type of question is given in the sample paper. You can try that and you can let me know what the answer you are getting. Okay, let's move to next question, that is question number 4. So this option C is the correct. Let's move to question number 4. So in question number 4, what we have been asked, that a fair dice is rolled 2 times independently, given that the outcome is on the first roll is a 1. So we have given that the outcome of the first roll is 1. The expected value of the sum of 2 outcome is, the expected value of the sum of the expected value of the sum of 2 outcomes. Okay, so if here dice is rolled 2 times, right? So the possible outcome will be 1 2 3 4 5 6. So these are the possible outcome, and so since it is a fair dice, it will have equally probable, so it will be 1 by 6. So on first roll or when we roll the dice, getting 1 have the probability 1 by 6, and similarly 2 3 4 all have the probability 1 by 6, right? And given that the outcome of the first roll is 1, right? So first roll we have given that the outcome is 1, so and that 1, that will have the probability 1 by 6, right? And so we have not given this So we have to find the expected value, right? Let's take someone expected value of x. The sum of the, so here we have given the sum of the two outcomes is expected value of the sum of the two outcomes. So if we have given on the first roll 1, that is fixed, so in second roll what we can get is 1, right? And in first roll we are given that 1, so second we get 2. So I hope you get this, right? Because in the question we have given that that the first roll is 1, and in second roll we can get all these things, right? So we have to find the expected value of the sum of the outcome. So sum of the outcome will be 2, 3, 4, 5, 6, 7, right? And so okay, so we have to find the expected value, right? Of the sum 2 plus 3 plus 4 plus 5 plus 6 plus 7 divided by 1, 2, 3, 4, 5, 6, 6. So 2 plus 3 5 plus 4 9 plus 5 14 plus 6 20, that is 27 divided by 6. So it will be 4.5. Expected value of something. So this is yes, correct answer. So option B is correct. So for question 4, option B is the correct one. Right, now we can move to next question, that is question number 7, and this question is from the order statistics. So I don't think so that this type of question will be asked in the data science. So I am skipping this question. If you know, then you can try. Let's move to next question, that is question number 8. Right, so 8 number. Let x and x and be random sample drawn from the population with probability density function, that we have given that this probability density function and the sample has been drawn from this probability density function, and these are the sample x1 x2 and till xn. The maximum likelihood estimator of theta is, so we will have to find the maximum what value of the theta we will have the maximum probability, right? So we will have to find that. So if you are already doing machine learning and if you observe that this kind of scenario you have already gone through that, right? So I think in logistic regression we are using this maximum likelihood also. So in lot of to find the parameter we are using this MLE, right? So okay, let's solve this question. So we have given this probability density function, that is f x and parameterized by theta, is equal to theta x theta minus 1, right? And sorry, and this x belongs to from 0 to 1 and theta is greater than 0, right? So we have given this, and from this we have taken n sample, and these samples are x1 till xn, right? So the first point is to write the so all the sample will have the same PDF, same probability density function. So this if I ask that what will be the PDF of this x1, that first sample, that will be xn is equals to theta x theta minus 1. Similarly, that x2 will have the same PDF, right? And similarly, that x1 sample will have the same probability density function. Now if I ask you that how you can write the maximum likelihood function, so the maximum likelihood function, let's denote it as L, and let's suppose that it is the function of parameter theta. So we can write maximum likelihood function as the product of the product of the PDF of these samples, right? So here we will have x of I, right? And I will be from 1 to n, right? And so to find this value of theta, what we will have to do is first we will have to, so let's first of all put this n, so this xi is theta, x to the power theta minus 1, right? And for h, so here it will be x of I, right? Because that will be the product of each sample, product of the PDF of each sample, right? So that is your likelihood function. Now we have to find that this value, at what value of theta this likelihood function will be maximum, right? So how we can find that? That is simple. What we can do, we can take the differentiation of this and we can equate it to 0, and whatever the theta we will get, that theta will give you the maximum likelihood. So before that, what we can do, we can take the log likelihood. So log theta, take the log. So why we are taking the log, and also that at whatever the value, at what value, so this is log likely, right? And this is likelihood. So let's suppose that your log likelihood at maximum at this value of the theta likelihood function. So if you are taking the log, again you will get the maximum at theta itself. Maybe this height will be normalized, but but at the same value of theta you will get the, and we are taking the log to make this calculation easy. You will see that taking the differentiation will be easy. So you can take log of this, so x of I theta minus 1, right? So if you take the log of this product and if you expand the log, that product will get converted into summation I is equals to 1 to n, and here we will have log theta, right? And let's take log e to the power theta and plus log e to the power xi theta minus I 1, theta minus 1, right? Now now what we can do, we can take the d upon d theta of this log. Okay, so let's take this in next step, right? So log likelihood with respect to theta, we are taking the differentiation, right? So we are taking with respect to theta, so log ln theta will be 1 by theta, and this summation will be there, right? 1 plus if we take this, then it will be theta minus 1 and log of e to the power, so this theta minus 1 will be in at the front, right? So let me first of all expand this one, so it will be theta minus 1 log e to the power xi, right? Now if we take the differentiation, what we will get with respect to theta, here log xi, right? Here we will have log e to the power xi, and next term will be 0 because that will be treated as constant, and here we will have the summation term 1 to n, right? Now maybe we can break down this summation, and now we will have to equate it to 0 to find at what value of theta we will get the maximum value. Now let's we can write this, so this will get sum up to n times, so it will be n by theta plus, here we will have this log e to the power xi, and this sum term will be there, right, equals to 1 to 0, right? And from here we will have to find the value of theta, right? So we can, what we can do, n by theta is equal to minus times of 1 to n log e to the power xi, and from here we can get the value of theta, that theta will be minus of n divided by summation of I is equals to 1 to n log e to the power xi. So this is the, at this value of theta, the log likelihood function will be maximum, and at the same value of theta, this log likelihood function will be, so this likelihood function will be maximum. So we have got this theta value, and if you look at this option, option A is the correct. Right, now we can move to next question. So this question number 10 is from the, I think, linear regression, that you can try it out. And this question number 13 is from the multivariant Gaussian random variable. I don't think so that we will be asked question based on the multivariant, so I am skipping this. You can try it out. Now let's move to this question number 16. Okay, so that is all. Okay, Okay, so this question number 16. For k is equals to 1 to 10, let the probability density function of random variable xk be. So we have given the probability density function of each sample, I can say that xk. So for x1, x2, x3 up to x5, x10, right? Then we have to find the expected value of this is equal to. All right, so how we can do that? So first of all, let's look at this expected value inside the expected value. So we have given that for k is equals to 1 to 10, k times xk, right? And we have given this probability density function for each x, right? So if I, so let's look at this first of all. So summation of k is equals to 1 to 10 k xk, so it will be 1 times x1 plus 2 times x2, right, plus 3 times x3 till 10 times x4, right? And we have given the density function for each probability density function for each xk, right? So for x1 we have given this probability density function, right? So for this x1, that x1 we what it will be, e to the power minus of x divided by 1 for x greater than 0 and 0 otherwise. And similarly for x2 we have given this e to the power minus x divided by 2 from here for x greater than 0 and 0 otherwise. Similarly for x3, the probability density function will be e to the power minus x divided by 3 for x greater than 0 and 0 for otherwise, right? Now first of all, now you see that you will have to take the expectation of all these, right? So you will have to find the expected value of this, expected value of this, expected value of this, and so on. Then you will get this, right? So okay, so there must be something in general, right? Because we are not going to calculate the all these 10 expectations, so we will have to find the pattern somewhere, right? So let's first of all calculate this expected value of x1. So if you know the formula, that will be from 0 to infinity, because for less than 0 it is 0, right? So from 0 to infinity, x into probability density function. So probability density function is e to the power minus x. So what it will be? So for that, let me remind that what is the integration of e to the power ax, right? So integration of e to the power ax is e to the power ax into x divided by a minus 1 divided by a square, right? So you can use this and you can directly evaluate this one. So here what we are going to get is, here if you see that a is minus 1, right? So let me write it will be e to the power minus x, and we have x divided by a, right? So here we will get x minus x because a is minus 1, and plus 1 divided by a, but we will not get plus because a square will be plus and overall we will get minus, right? So minus 1. Okay, let's not put this limit as of now because for every integration calculation we will have this limit, right? So now let's calculate this expected value of x2. So again it will be from 0 to infinity, but now this time we will have here 2, I think, right? So 2 will be there, and x2 is again e to the power x divided by 2, and this also we have divided by 2, right? So that 2 will get cancelled. Here we have divided by 2, so this 2 will get cancelled, right? Now we can find the integration of this, so it will be e to the power minus x divided by 2, and here we will get so it is minus of x, so x 2x 9, no, I think a, right? So yeah, right, and here will get minus 4. Correct. Okay, I hope I'm not making any mistake. So if at the end we will have to add up, right? So if we add these two, okay, let's put the limit also. Let me think. So here what we are going to get is e to the power minus infinity, that will be complete 0, and if we put 0, so here we will have minus 1 and this minus 1, so overall we are going to get 1, right? 0, that will be minus and minus, so here we are going to get ultimate 1, right? And if we put the limit here 0 to infinity, what we are going to get is that infinity will be 0 and minus here we are going to get is 4, right? Plus 4. Okay, so when we will calculate this e to the power x3, what we will be getting is 9, right? Because this is square, this 1 divided by a is getting reflected here, so 1 here, a is 1 by 2, so we will be getting 4, so here we will get 9. Okay, I think that expected value will be sum of 1 plus 2 square plus 3 square plus 4 square dot 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 10 square, right? So you will have to find the sum of this. So what's the formula for sum of the I think I forgot, n plus 1 into 2n plus 1 divided by 6, is it right? 11 into, so 20 into 21 divided by 6, n into, I think n is also there, into 10, so 5 3 7 35 35 385. Okay, so the correct answer for this is 385. Okay. Okay, now let's move to next question, that is question number 17. Let me check this 16. 16. Okay, 385. Okay, now let's move to next question, that is question number 17. The probability density function of random vector xy is given by, so we have given this PDF, the value of c is equal to, okay, so we have given this probability of x comma y is equal to c when x is greater than 0 and y is greater than x and less than 1 and 0 otherwise, the value of c. So you have to make the use of the property of the density function, right? So if you integrate through the complete interval, then that probability of density function will be add up to 1, right? So that, so for the limit will vary from, for x the limit will vary from, for x limit will vary from 0 to y, and for y limit will vary from 0 to 1, right? And if you integrate this fxy dx dy, then it should be equal to 1, right? Then we will get the value of c, right? So for y is equal to 0 to 1 and x is equal to 0 to y, f this probability density function is given c, right? Dx dy is equal to 1. So first you can integrate with respect to this x. So y will be from 0 to 1, and here we will have x, limit will go from 0 to y, dy is equal to 1, right? So c 0 to 1, here what we are going to get is y, dy is equal to 1. Now c into y square divided by 2, so 1 divided by 2 is equal to 1, so c is equal to 2. So the correct answer for this is 2. So 72. Okay, now let's move to next question, that is question number 18. Okay, so we have given that let xn be a sequence of independent and identically distributed normal random variables with mean 4 and variance y. Then we have to calculate this term, random variable. Okay, so we have given that this sequence of set of random variables, and here n is greater than equals to 1. So basically we have given this one, x1 x2 x3, all these things we have given, right, till xn. So and all these are the independent IID, right? And these are the normal random variable, right? And with the mean 4 and variance 1, right? Then we have to calculate this limit n tends to infinity, probability 1 divided by n summation I is equals to 1 to n xi is greater than 4.0006. So we have to calculate this probability, right? So let's focus first of all, I add this term inside this, right? So if you expand this so it will be 1 by n summation of all those normal distribution, right? x1 plus x2 plus x3 till xn, right? So this is what you will get. Now you have to know that if you add two normal distribution, let's suppose that this x1 is normally distributed and it has mean mu1 and variance sigma 1 square, and let's suppose that you have the second sample that is normally distributed and it has mean mu2 and variance sigma 2 square. Now if these are two IID independent and identically distributed normal random variable, then sum will be also a normal random variable, and it will have the mean that will be the sum of these two, and it will have the variance that will be the sum of these two, right? And from where we are getting this? So if you are doing this sum, so you will have to do the convolution of these two normal random variable, and after doing the convolution you will get, finally you will find that in the last result that these means are getting added and these variance are getting added, right? So this is the part of theory that you should know, that these results you should know. So if you see that what we have here is sum of the n random variable, sorry, sum of the n normal random variables, and it has the mean that is 4 and variance 1. So so let's call this all as x. So x is the summation of all this. So now this x will be normally distributed and it will have the mean. So it has the 4 plus 4 plus 4 plus 4, so it will have the mean 4n, and variance will be 1 plus 1 plus 1 plus 1, so n, right? Right. So now this problem will be get converted into this, right? So it will be probability that this random variable x is greater than, and this 1 by term, so let's take this one to right hand side, so it will be 4.0006 n. So we will have to find the, so this x is randomly, so this x is again normally distributed and it has mean at 4n and variance is n, right? And we have been asked that what will be the probability such that it is greater than 4.006 n, right? So maybe 4.006 n will be somewhere here, and we have been asked that what will be the probability. So you have to calculate this area, right? And before that you will have to take this also, limit n tends to infinity. So here, so if you write the density function of this, so how it will look like? So it will be 1 divided by 2 root over 2 pi sigma square. So sigma square is n, right? So sigma square, that sigma is n, right? And e to the power minus of x minus 4n, right? Because mean is 4n divided by 2 into sigma square is n. Now what, so okay, now if we take this limit inside, then you see that this limit n is is infinity, that n will be infinity, then this whole term will get 0, right? So 0 is the answer for this question. Okay, now let's move to next question, that is question number 19. Okay, we have a lot of questions. Okay, let's stop this video till question number 18. Tomorrow we will start from question number 19, 20, 21. All these questions are this one is from hypothesis, I think. This one, hypothesis testing, and okay, we will do tomorrow because this length of the video has been already exceeded, so we will do tomorrow from 19, 20, 21, 24, and we have a lot of questions. Okay, okay, that is all about this video. Thank you.